Perfect. Thanks. All right. Thanks, everyone. That was great, Josh. Thank you. Tonight, I'd like to continue on with the small wind conversation we started last week. Was everybody here, or who wasn't here the last week? Okay, a couple, 3 people. Okay, so last week, just briefly went through the different types of technologies that are out there for small wind, and basically some preliminary things to think about with design of turbines. So this is meant to be a continuation on that. If there are things that are lacking, feel free to jump in and ask questions. I also felt like last week was a lot of us giving information out, and by all means, I'd like this to be more interactive and more, I guess, directed by you and what kind of questions you have to speak about with small wind. So just a quick outline of what I hope to get through. Oops, that was it. The first thing is basically trying to figure out how much wind you have available to you at your homes. This could be at your business or at your cottage. And then basically how you go about choosing the right turbine for your needs. So after you finally figure that out and you start making electricity, well, there's a whole bunch of ways you can use that power. We talked about selling it back to the grid. You can do that with wind, and you can store it in batteries. You can get paid for that, or it can cancel out or cut back on your amount of electricity you bring from your utility provider. And this all kind of relates to paybacks. So what are those? And that oftentimes that's what a lot of people want to know about. What are the paybacks in the system? And then we'll get into the sort of any concerns that perhaps you might not have thought about. A lot of people associate wind power with noise, and there's definitely some noise to think about. But there's also some pretty serious safety concerns and some maintenance considerations to go along with that as well. So the wind availability. This is every day inevitably somebody comes in to ask me about wind turbines, and I think a lot of people are just fascinated by the idea of wind, like seeing the propeller spinning and gathering their own power. I think it has a pretty organic kind of feel or something because people are really drawn to it. But in our area, on the lake, around the lakeshore, for sure we have a lot of wind available to us. But inland, not so much. So it really depends on where you are. Now, just like Dr. Pierce said, where if you have neighbors with trees and you have shade, well, solar might not make sense for you. If you have a cottage that's nestled in the trees, away from the lake, and you really want to get off the grid, solar might not be that good, but you could put a turbine up on the bluff on the lake or something like that. So what this picture is, it's from the Canadian Wind Atlas. Everybody can get this. It's online, and I'll provide the links for that. Basically, you can go in and you can just go in and put your position, and it will tell you how much wind you have available to you as a seasonal average. So a lot of people say, well, can't you just come out with some sort of device and measure the wind? And yeah, we can, but it'll be just during that day. So if it's a freak storm, you'll have really a lot of wind, but you're not going to have that all the time. So this is meant to give you that either seasonal or annual average, and that's really what you need to talk about when you're talking about wind. So the more red, well, there's no red on this map, but the more yellow, the stronger the wind region. So you can see that's the lake contour there. Yeah?
How much local variability is there that's not shown here? Like when they built the wind farm on Wolf Island,
yes.
Like they put anemometers up for a long time.
Exactly, and I mean that's prudent to do that because you're investing a lot of money, and you want to make sure that those efficiencies down to the under 1% are really looked at carefully. On your home sort of situation, basically this will get into a rough ballpark first to even let you know if it's feasible where you are. If you're up in the dark blue areas, then chances are it's not going to be. But there's a lot of local factors that change that as well. If you're in a valley, and there's a wind tunnel coming through there, or if you're up on a knoll, if you're on a lake or a stream or something that channels the wind, then that could affect it as well. So it's a combination of this and talking to you and us coming out and looking at your actual site. So there are things that we can look at, like the way the trees are blown. If the limbs are all pushed off to the sides of the trees, and the prevailing wind directions, and you can make a good guess at what's going on. So combining these numbers with that will give us a pretty good approximation. You can get a data logger, set it up for yourself, and see that as well. It's a couple to a few $1,000s to set up a system like that, and generally, if you're talking about a project that's $15,000 to $20,000, it doesn't make a lot of sense. If you're putting up a $450 million wind farm, it makes sense.
Jason, question just around
Yep.
When folks like Canadian hydro developers over Wolf Island,
Yeah.
when they log the wind, is that data publicly available?
No. So it's not available. That was one thing I asked them as well. One of the biggest things with wind power, and I talked about this last week, is those machines over there, each one of those turbines you see on the horizon have a capacity of 2.3 megawatts, but they're not going to produce that much all the time. And they use this data with their anemometers, and they try to figure out how much they're going to get for their return on their investments. Generally, with small wind, you can kind of bank on a quarter to a third, just as rough rules of the rated capacity that you'll get on average over the year. So, if you have a 1,000-watt generator or a kilowatt, maybe you're 250 to 300 watts of power out of that you can average over the year. But that really depends on your site.
What elevation includes winds?
Yeah, that's a great point. So this one is at 30 meters, okay, which is quite high. So obviously at your home, you're not going to go up 30 meters generally. You can, of course, the wind velocity goes up quite a bit with height, and the power you get out of a turbine is the cubic of the velocity. So it makes a lot of sense to get that turbine, whatever power it can produce, get it up as high as you can into the cleanest wind. This generally, you need about 4 to 4.5 meters a second, or 9 to 10 miles an hour wind, just a sec, to get you to kind of be feasible for your area. And you can see that that's sort of this dark to light blue. So there are a lot of areas around here where you're borderline okay for small wind.
Do you ever rent weather stations?
Pardon?
Do you ever rent the weather stations?
No, we only have. We actually don't have a data logger either, just because it's never been a feasible assessment for us. We have a handheld anemometer, but no, we don't rent them. Okay.
Sorry.
Yeah, sure.
Are there seasons that you don't have the windmill, the turbine generating electricity?
Pardon? Say that again.
Are there seasons that
There-
you don't have the turbines generating electricity?
Yeah, there are cities that don't have them.
I mean seasons. Like
Seasons,
period,
yes. Yeah.
when you don't have the turbine generating electricity.
Pardon me. I'm sorry. I just can't.
So I said, do you have within a year?
Yeah.
Do you have a period where the turbine
Isn't
would
generating?
not? Yeah.
Oh yeah, perfect. Yeah, I understand now. Definitely, there is a seasonal variability, and what's kind of good about this with solar is that they kind of operate on different seasons. So in the summertime, when it's really hot and sticky and dry, and those hot summer nights, not dry, no wind, that's the worst time for wind, but it's the best for solar. And then the opposite is true when we have those fall, winter, spring storms. You get a lot of great wind, but not very much sun. So they tie in quite well with each other. And that's something to really think about if you're trying to get to that 100% of your load through renewable energy. They do work well together.
Do they tie in with the 90-day